Assalamualaikum dan salam sejahtera. Okay, so today our lecture will be on mode of heat transfer. Okay, so what is heat transfer? As you can see here, so a glass of hot coffee. Okay, in the morning, the temperature is at 70 degrees C. Okay, so you will be realize that after one period of time, your hot coffee will become cold. Okay, the temperature will be equal to the surrounding temperature. Okay, so that is the common phenomena that can be seen every day about the phenomena of heat transfer. Okay, so in other words, heat transfer will be happen when there are temperature difference. Okay, so the important medium for the heat transfer is temperature difference. Okay, so from 70 degrees C to 20 degrees C to the environment, to the surrounding environment. Okay, so that is the direction of heat transfer from hot to cold temperature. Okay, and then as I mentioned, to satisfy the zeroth law of thermodynamics, the hot coffee will be cold after some period of time when the temperature reach the equilibrium state. Okay, so there is heat. So what is heat? Heat basically is a form of energy. Okay, heat is a form of energy. So it can be transferred from one system to another system. Okay, as a result of heat transfer. Okay, so that is the most important keywords for heat transfer. There must be temperature difference, and then direction must be from high temperature to cold temperature. Okay, so that is our keywords for heat transfer. Okay, what is heat transfer? In definition, it is a physical process by which heat energy move from one area to another area. Okay, so there must be a direction. Okay, as I mentioned, from hot to cold, from high temperature to low temperature. Okay, so there is heat transfer. And then heat transfer, we will be learning about the rate of energy. Okay, rate of energy, or in other words, Q. Okay, rate of energy in thermodynamics, in thermal engineering, we define it as Q. Okay, so the determinant of rate of energy, it is defined as Q. Okay, so Q dot, so rate of energy. Okay, so what is the unit? Unit must be watts. Okay, so what is watt? It is joule per second. Okay, so when you are asked about rate of energy, it must be Q in engineering term. Okay, and then dot is referred to the rate. Okay, what is rate? Rate must be the unit of energy per unit of time. Okay, S is time. Okay, so that is the rate of energy transfer. Okay, and then so it is occur when the difference temperature exists in a medium or between media. The transfer of heat is normally from high to a lower temperature, as I repeatedly mentioned before. Okay, so heat only will be transferred from high temperature to lower temperature as a common. Okay, so in other words, if you want to transfer heat from lower temperature to high temperature, okay, which is in the reverse direction, you need a special device. Okay, and then what is this device? The device is known as a refrigerator. Okay, so that we will be learning in chapter 4. Okay, so refrigerator is a device that is used to transfer heat from low temperature region to high temperature region. Okay, so don't worry, we will be learn this in chapter 4. Okay, so introduction of mode of heat transfer. So what is mode of heat? How the heat will be transferred from one direction, from one places to another place, from one point to another point. Okay, so there are three type of heat transfer, the medium of heat transfer. The first one, as you can see in this, as you can see, okay, as you can see here. So there are fire here from wood, okay, and then there are apa ni, tangan, okay, and then ni stick, steel stick. Okay, so as you can see here, the first one is convection, and then conduction. There are advection, which is combination of conduction and convection, and then radiation. Okay, so basically there are three mode of heat transfer, which is conduction. Okay, so what is conduction? Bear in mind, conduction is one mode of heat transfer that is based on solid medium. Okay, so there is the conduction. The second one is convection. So convection, the keywords is the moving fluid. Okay, so meaning that convection happen when there are moving fluid. Okay, so moving fluid such as it can be water, it can be steam, it can be air. Okay, so there is convection. And then the last one is radiation. Okay, so radiation is a mode of heat transfer that emitted heat based on electromagnetic wave. Okay, so there is mode of heat transfer. Okay, so as you can see here, there are two phenomena that can describe all these three type of heat transfer. Okay, so as you can see here, the a room, okay, it is during the winter. Okay, so definitely not in Malaysia. Okay, this is winter, so in order to get or to get a hotter temperature, there will be this fire. Okay, and then radiation means that there are transfer of energy or transfer of heat through the electromagnetic wave. Okay, so there is the radiation. Okay, for example, when we boiling the water, okay, using pan, okay, boiling water, or you are cooking some dishes. Okay, so fire from your gas stove, okay, directly hit the pan, okay, kuali periuk. Okay, and then the direct impact of heat from the fire is known as radiation. Okay, the same goes for the solar energy. There are direct heat from sun that will impact our body, our car, and then our roof ataupun wall rumah. Okay, so there is the radiation. Okay, and then convection. As you can see here, convection. Why it is convection? Because there the smoke, okay, smoke, the hot smoke, hot temperature smoke will be flowing through this channel. Okay, so that is convection. Okay, so as I mentioned before, convection only happen when there are moving fluid. Okay, smoke is part of fluid, so that must be convection. Okay, and then there are convection around window and door, which is the cold air entering through the window. Okay, so there is the convection. And then conduction. Okay, conduction through this floor. Okay, so floor mean that it is a solid medium, so there is a conduction. Okay, so these are three mechanism of heat heat transfer. Okay, so the first one, conduction. What is conduction in definition? Okay, the transfer of energy from more energetic particle, okay, of substance to the adjacent, to the closest, to the near less energetic ones as a result of interaction between the particle. Okay, so that is the conduction definition for the conduction. Okay, so as you can see here, there are hand here. Okay, maybe it is a spoon. Okay, so hot temperature will be transferred to this hand via conduction. Okay, so if it is a steel ataupun it is a spoon, spoon is a good conductor. Okay, so that's why heat will be filled by this hand. Okay, so there are called conduction. Okay, so in terms of molecular structure, you can read here. More energetic mean that hot particle to the cold particle, okay, and then it collides, berlanggar, and then hot particles collide with cold particle, and then after the collision there will be vibration. Okay, so two particles have similar energy level, both are warm. Okay, so there is definition of conduction in context of molecular structure. Okay, so that is conduction. And then in a very brief view, how to see the collision of atoms, okay, and then how the vibration occur, you can see this slide. Okay, so conduction in solid is due to the combination of vibration. Okay, there are collision and then there will be a vibration of the molecules in a lattice and energy transport by free electron. Okay, so heat from this candle, okay, will be heated the metal. Okay, and then if we view in terms of molecular structure, you can see the atomic structure of this metal. Okay, so and then temperature will be transferred, okay, from the to the adjacent of less energetic, okay, from more energetic to the less energetic particle. Okay, atoms are energized and vibration increase. Okay, there will be vibration, and then what happened? Vibration is spread through the material. Okay, atoms are energized and vibration increase. So this is how the conduction happen. Okay, so conduction can also happen not only in solid, in metal, in wood, in brick. Okay, so it is also happen in liquid and gases. Okay, so it is due to the collision and diffusion of the molecules during their random motion. Okay, so there is liquid and gases. Okay. Okay, so conduction process of course there must be a temperature different. Okay, conduction will not happen if the temperature are equal. Okay, so from the warmer to the cooler object. Okay, so the transfer of heat between two bodies or two parts of the same body through molecules. The heat transfer that will occur across the medium in solid, liquid, and gas are from one to another. Okay, so what is the equation that will be used for conduction? Okay, so for the conduction, the equation or governing equation is known as Fourier's Law. Okay, so Fourier's Law of heat conduction. Okay, so Fourier's Law of heat conduction, it is equal to Q dot. Okay, as I mentioned before, Q dot here. Q dot is referred to the rate of heat transfer. COND is rate of heat transfer due to the conduction. Okay, and then this equal to negative K. What is K? K is thermal conductivity. Okay, so K is thermal conductivity. Okay, so thermal conductivity is different for different material. Okay, so the unit of unit for K. Okay, unit for K stand for thermal conductivity. Okay, K thermal conductivity, and then the unit must be watt equal to meter per Kelvin or watt per meter degree C. Okay, so it is equal watt per meter Kelvin ataupun watt per meter degree C. Okay, so K is thermal conductivity, and then A. What is A? A is area. Okay, luas. Okay, luas kawasan, area that is in normal direction with the direction of heat. Okay, so I repeat, area is area for particular material, okay, that is normal to the direction of heat. Okay, area, the unit is meter square. Okay, so dt dx, okay, dt dx is known as temperature gradient. Okay, so dt, in other words, dt is T hot minus T cold divided by dx. Okay, so what is dx? dx is thickness. dx is equal to thickness, and the unit must be meter. Okay, th minus tc, unit must be Kelvin or degree Celsius. Okay, so that is all about Fouriers law of heat conduction. Okay, so the unit for the Q must be joule per second ataupun watts. Okay, joule per second ataupun watt. Okay, okay, so as you can see here, so I need to erase this one. So this schematic, this diagram shows on how to apply the how to calculate the Q dot through the conduction. Okay, through dot via conduction. Okay, let's imagine this is your wall, your home wall. Okay, your home wall temperature will be transferred from outer temperature, okay, which is surrounding temperature, to the inner temperature, which is inside your house, which is T2. Okay, so mode of heat transfer must be from high temperature, which is outer temperature, to the inner temperature. Okay, so there is the direction, and then this is A. A is the area. Okay, so the area, if you can see in this direction, okay, okay, so if you see from this view, okay, if you see from this view, you can see your wall is basically like this. Okay, so where is the area? Okay, so the area is, if we change in this direction, so this is your area. Okay, and then what is dx? Dx is thickness. Okay, thickness of your wall. Okay, thickness of your wall. Thickness. Okay, so based on this Fouriers law of heat conduction, it is mentioned that about the rate of heat transfer. The rate of heat transfer is linearly, okay, linearly proportional to the temperature gradient. Okay, so dt over dx. If you want to increase your heat transfer, if you want to increase the heat transfer, you can either increase the temperature. Okay, you can increase the temperature. Increase the temperature mean that the Q dot also increase. Okay, or if you want to reduce the Q dot, okay, reduce the Q dot. For example, heat from sun, okay, directly hit our home wall, and then we want to reduce the rate of heat transfer. Okay, what happened? We need to increase the how to reduce the Q dot conduction. We need to increase the dx. Okay, dx, which is increase the thickness. Okay, by increasing the thickness, you will decrease the Q dot. Okay, so there is the relation between rate of heat transfer and also the equation of Fouriers law, Ka dt over dx. Okay, so this is the equation. Okay, as I mentioned, so what is temperature gradient? Normal to the direction of heat transfer. So it has been mentioned in the previous slide. Okay, so what is thermal conductivity? Okay, so as you can see, if you want to have a very high Q dot, okay, Q dot conduction, you can either increase the temperature difference, or you can also increase the thermal conductivity. Okay, so thermal conductivity is the rate of heat transfer through a unit thickness of material per unit area per unit temperature difference. So what is this? Basically, it is only definition based on unit. Okay, watt per meter degree C. Okay, per unit area per unit temperature. Okay, so that is the thermal conductivity. Okay, so thermal conductivity of material, the function is to indicate the ability of the material to conduct heat. Okay, the symbol is small k. Okay, not a capital K. The symbol must be small k. Then the unit repeatedly mentioned watt per meter Kelvin ataupun watt per meter degree C. Okay, so thermal conductivity, there will be high value, there will be low value of thermal conductivity. Okay, so what is the function of high value of thermal conductivity? So high value for thermal conductivity indicates that the material is a good heat conductor. Okay, so good heat conductor mean that is, for example, in order to transfer the electricity. Okay, so we must have a good heat conductor. Okay, copper, for example. Okay, copper wire. So there is a good heat conductor. So the value of copper, the thermal conductivity for the copper is very high. Okay, and then a low value indicates that the material is a poor heat conductor or insulator. Okay, so kalau if it is a poor heat conductor, it is also equal to insulator. We want to insulate. Okay, we want to insulate to lower, to decrease the rate of heat transfer. Okay, for example, your how to say that, your home wall. Okay, your home wall will be basically will be covered by two-sided of plaster. Okay, so the function of plaster is basically to reduce, okay, to reduce the heat transfer. Okay, and then the cement plaster basically react as an insulator. Okay, so this is an example of good conductor and bad conductor. So the wooden handle is a good insulator, meaning that good insulator, the value of K is very low. However, for the metal body, it is a good conductor of heat. Okay, kita nak cepat panas, so we must use a very good ataupun very high value of K, thermal conductivity. So this is some example of thermal conductivity of some material. Diamond, 2300 watt per meter degree C. Okay, so this is common that being used in your field. Okay, in the electric to flow the electricity, we use copper. Okay, so copper wire the K is high for 0, 0, 1. Okay, so let's move to the material that have a very low thermal conductivity. Okay, so for example water. Okay, for example glass fiber. So glass fiber is also used for insulator. Okay, sebab apa? Because the glass fiber, the value of how to say that, the value of thermal conductivity is very low. Okay, so brick only 0.72. Butter nak buat rumah tu, so brick is 0.72 and then glass is 0.78. Okay, so this is thermal conductivity of material. So in terms of graphical value, high thermal conductivity, it is pure metal. Low thermal conductivity is for the gases. For the insulation system, okay, we can use foams and also fibers. Okay, liquid, oil, water, and mercury. Okay, so thermal conductivity of material are temperature dependent. Okay, what is temperature dependent? High temperature, the thermal conductivity is directly proportional to the temperature of that particular material. So as you can see, temperature increase. Okay, so there are temperature at 1000 Kelvin. Okay, so thermal conductivity is reduced. Okay, the temperature independent, not temperature dependent. Sorry for the typo. Temperature independent. Okay, temperature increase. Part of the material also increase for the thermal conductivity. Okay, so this is for the gases. Okay, gases. And then also water, also gas for the liquid. There are another term that is known as alpha. Okay, alpha is thermal diffusivity. Diffusivity in conduction. Okay, so what is alpha ataupun thermal diffusivity? It is the ratio of the heat conducted through the material to the heat stored per unit volume. Okay, ataupun in other words, thermal diffusivity is a measure of how fast the heat will be transferred through that particular material. Okay, kita tengok berapa laju. So it is a thermal diffusivity. Okay, so we skip this example so that we can do this example in our synchronous lecture. Okay, so that is conduction, the first mode of heat transfer. Okay, let's move to the convection process, which is the second mode of heat transfer. Okay, let's recall, convection is a process in which the presence of moving fluid. Okay, it can be air, it can be gases, it can be steam, it can be water. As long as it is moving, so it is a convection process. Okay, so it is occur between the solid surface and moving fluid at different temperature. Okay, so for example, steam in power plant. Steam in power plant. Okay, to produce the electricity. Steam in particular pipe is moving. Okay, moving, and then the motion will induce the convection process. Okay, and then the steam is moving inside the solid pipe. Okay, so that means that there are solid surface and also moving fluid at different temperature. So heat will be transferred. Okay, so the combined effect of conduction and fluid motion, change of phase of fluid also considered to be a convection. Okay, so this is some example of convection. Hot air rising from the earth. Okay, and then air cools off, and then there are cycling process, cool air sinking. Okay, so hot surface heat surrounding air. Okay, here warm air rises. Okay, air is replaced by cool air, and then circulation begins. So it is a circulation process. Okay, for example, for the convection process there are two types, which is forced convection and natural convection. Okay, as you can see here, if you are using any forced medium such as fan, compressor to cool or to move the fluid, it is known as force. Maknanya ada forcing force, okay, forcing medium. Okay, so there is known as forced convection. Okay, natural convection means that it is based on buoyancy effect. Nothing. We just put the hot egg in the surrounding temperature, in the surrounding room, and then we just let the hot egg become cold. So that is natural convection. And then forced convection. Okay, so this is natural convection. Cooling, it is the fluid motion is caused by buoyancy force, as I mentioned. They are induced by density differences due to the variation of temperature in the fluid. Okay, so what is force? Kalau ada force, must external means such as fan, pump ataupun wind. Okay, so there is forced convection. So there is some hydrological cycle for the convection process. Okay, so there is also convection process inside the kettle. Okay, so there are moving fluid due to the heat. Okay, cool molecules and then warm molecules interact so that the convection will be happen. Okay, so in boiling water it is also convection. Okay, so in cold glass during the hot day, okay, you will notice that there are some droplet on your glass, okay, around your glass of water. So this is because of condensation. Okay, because of the condensation. Okay, so this is all example of convection process. Okay, if the conduction is using the Fouriers law, convection is using the Newton's law of cooling state. Okay, so the rate of heat transfer is observed to be proportional to the temperature difference. Okay, so Q dot convection equal to HA Ts minus T ambient. Okay, so H is known as H is not thermal conductivity. So because we are not considering the solid, we are considering the moving fluid because we are now dealing with convection. Okay, so dealing for the H, it is convection heat transfer coefficient. Okay, convection heat transfer coefficient. Okay, and then the unit is watt per meter square degree C, ataupun it is similar to watt per meter square Kelvin. Okay, so that is the unit. As you can see here, this is the different with the thermal conductivity. So meter square means that it must be per unit area. Okay, per unit area. Okay, so this is the area sama, which is the area that is passing through by the moving fluid. Ts over T hot, okay, T stream minus T ambient, ataupun T hot minus T surrounding temperature different. Okay, so unit still same, watts. Okay, so let's see the example. Okay, how this is the convection heat transfer coefficient. H is not a property of the fluid. It is an experimentally determined parameter whose value depends on surface geometry, nature of fluid motion, how fast the fluid is motion. For the surface geometry, how it is related to the friction, okay, friction of that particular surface geometry. And then properties of the fluid, the Reynolds number, for example, okay, the viscosity, kelikatan, okay. So it is the properties of the fluid, and then the bulk fluid velocity. Okay, so in other words, H is not a fixed value. Okay, H must be determined. Okay, H must be determined. H must be determined. It is not like K. K is a fixed value because K is depend on thermal conductivity for that particular material. Mean that it is a fixed value. Okay, and then the last one, which is the radiation process. Okay, radiation as I mentioned, it is emitted heat via the electromagnetic wave. Okay, so that is the radiation. Interact with matter via either emission, light is released. For example, light is released, you turn on your light, so it is emission. Absorption is light is captured. Okay, if you capture the light, so it is absorbed. Transmission, light is allowed to pass through, and then reflection is light is bounced away. Okay, so radiation process is the transmission of heat energy by rays passing from a heat source to an absorbing material. Okay, so the energy emitted by matter in the form of electromagnetic wave ataupun photons. Okay, so does not require any intermediate medium for energy transfer. For the radiation, does not hit any medium. Okay, kalau conduction we need solid medium. Kalau radiation convection we need combination between solid and moving fluid medium. Okay, so but not for the radiation. Okay, it can take place in a vacuum. Okay, without a moving fluid. Heat from the sun reach us by infrared radiation. Okay, absorption of infrared radiation causes temperature rise. Okay, so thermal radiation process is the form of radiation, okay, emitted by bodies because of their temperature, and then it is a volumetric phenomenon, and all solids, liquid and gases emit, absorb or transmit radiation to varying degrees. Okay, so it differs from other form of electromagnetic radiation such as X-rays, gamma rays, microwave, radio wave and television wave that are not related to temperature. Okay, so this is some simple phenomena for the radiation. Okay, so as you can see here, person at 30 degrees C, fire at 90 degrees C. Okay, so the radiation from this hot temperature might be transferred to the body via the radiation. Okay, so solar incident energy, okay, the solar directed from sun towards the earth, okay, towards earth is also known as radiation. Okay, thermal radiation process, emission of infrared radiation causes the temperature of the object themselves to fall. Okay, so the rate of heat transfer by radiation is affected by the following factors. Okay, color and texture of the surface. Okay, color is affected by the radiation heat transfer. Okay, surface temperature and also surface area. Okay, for the radiation, we use equation that is known as Stefan-Boltzmann law. Okay, so the maximum rate of radiation that can be emitted from a surface at an absolute temperature T surface in Kelvin ataupun degree C is given by the Stefan-Boltzmann law. Okay, Q dot M equal to radiation and AS stands for surface area, T is surface temperature. Unit also watt, where alpha is the Stefan-Boltzmann constant. Okay, it is a fixed value, 5.67 kali 10 power of 10 power of 8 watt per meter square, Kelvin power of 4. Okay, so that is the radiation. Okay, so radiation, the idealized surface that emits radiation at this maximum rate is called a black body. Okay, so black body, what is black body? The radiation emitted by a black body is called black body radiation. Okay, so the radiation emitted by all real surface is less than the radiation emitted by a black body at the same temperature and is expressed as this equation. Okay, so where epsilon is the emissivity of the surface from 0 to 1. Okay, so the probability of emissivity whose value is in the range of 0 to 1 is a measure of how closely a surface approximates a black body for which epsilon equal to 1. Okay, so the net rate of radiation between two surfaces is given by this equation. Okay, in practice, in this KJM 442, we will be using the combined heat transfer coefficient that includes the effect of both convection and radiation. Okay, so then the total heat transfer is expressed as Q dot total H combined. Combined means that combination of between the convection and also radiation. Okay. Okay, so that's all for the mode of heat transfer, and then for the next lecture we will be learning about the how to calculate the rate of heat transfer for the convection, conduction, and also radiation. Okay, so thank you very much. Assalamualaikum dan salam sejahtera.